Hi, Rockies again. Last week, I got a partner call me and they got a problem about the network design. Actually, the end user requests some kind of a design to help them to reduce the fiber cost. Everybody knows already, when you deploy a network infra, other than calculating, the hardware equipment you have to buy, you also need to take into consideration about the fiber that you need to lay in the infrastructure. Sometimes if you need to lay very long distance fiber cable, the cost will be very high. So this week, I'm going to share something about the network design, how to reduce the fiber costs. So let's move forward. This is the design that my partner discussed with the end user, and then they come out say, oh, actually this customer got around like 5 floors: floor 1, floor 2, floor 3, floor 4, and floor 5. And each floor, they got like the vertical trunk. The vertical trunk, they divide into Zoom 1, Zoom 2, and Zoom 3. And the data center is located, in the middle of the floors. So right now they come to a design, say, if under the same Zoom, under the same vertical conduit, the vertical trunk, I can easily lay fiber cables, maybe like some longer distance fiber patch cord. I can link all the switches as a ring stack and form a ring. And I only need, to build or to lay fiber cables from each zone, only maybe 1 or 2 fiber cables or 1 fiber cables with multi-core coming to the core. So this will definitely reduce the cost of the fiber. And same in Zone 2 and same in Zone 3. So this is quite the logical design when you do this kind of a ring stack for all the switches, and then you put like a 2 uplink to the core switches. But before you do this design, I need to bring one consideration, which is very important, is the bandwidth consideration during your design. Normally, for one switch, right, you need to consider how many user port. Right now, everybody using gigabit switches. How many user port? Each port right now, we have a 1 gigabit. Assume like one switch, normally we come up with 48 port, maybe PoE connecting to the Wi-Fi AP, connecting to printers, whatever, or even computers. Theoretically, 48 gigabit port, it comes out 48 gigabit per second bandwidth required. If in one zone, you have 7 switches. 7 switches times 48 gigabit per second, it comes out 336 gigabit per second. And then you need to ask one question to yourself. What is your ring stack bandwidth? That means when you form a ring across all the switches in one zone, right? Is the bandwidth across the switches enough for you to run the total bandwidth? The second consideration is the uplink bandwidth. That means from this ring, what is the total bandwidth? It go up to the core switch. Is it 2 times 10 gigabits? Or you use higher speed 40 gig or even more expensive 100 gig? Normally, we have bear in mind, there is an overbooking ratio around 1 to 10. That means if you have 2 10 gig uplink, normally you can put like a 200 gigabit bandwidth for all the access switch coming together. That is equal to around like 4 times 4 48 port gigabit switch. That means you can step or you can do ring step for 4 gigabit switch together. So if we take out the ring step consideration, right? So here, I take out all the ring. So in each zone, right, in this floor, right, what you need to add is extra fiber, and this will definitely adding the cost. So you see in this design, right, this stack, you need to run the fiber directly to the core. This stack, you need to run another fiber to the core, right? So according to the same design, you need to lay extra, right? 1, 2, 3, 4, 5, 6. 6 locations access switch and you need to put the fiber from the locations to the core switch. Definitely, okay, the fiber cost will be very high. So whether we put the ring or we don't put the ring across 4, right? We need to compromise. So that means we have to create reasonable ring stack around like a 3 to 4 switches. That will be the best, okay, design for the whole network infrastructure. So what it is look like, you see here, we may like assume one. In the design, in the beginning, they have 7 units of switches. Then because we can take the advantage of the same vertical trunk to put a short distance multi-mode fiber to link all the switches together. So I can break it into 2 rings. In zone 3, I can also put it into 2 rings. So that means we only need to add extra, okay, 2 locations, okay, fiber to the core. Or sometimes, okay, we can use a multi-core fiber and using the existing, okay, fiber resources to run, okay, to the core. Say, if this ring stack in Zone 1, if this is like a 2-core or 4-core fiber, or 4-core or 6-core fiber already, I can run like a 210 gig, okay, up to the core switch, and then you don't need, okay, to put this one. So this kind of a design compromise, okay, the number of fiber you need to deploy in the real network. So this is the discussion and the sharing this week. Thank you for listening. Goodbye.